Hello, everyone. Good morning or good evening, depending on where you are. Hope you all are doing good and healthy. Welcome to the panel discussion on the topic Women in Transportation Electrification Community, organized as a part of IEEE PES Young Professional Powering the Future Summit. The mission of WITEC is to coordinate all things transportation, electricity, and smart within IEEE and bring more women into this field. Today, we have eminent ladies with us whom we can call as leaders in their domain. I welcome our panelists, Gokcin Cinar, Satarupa Bal, and Simay Akar to this panel discussion. I also welcome all our participants who are watching us live. Kindly drop your questions in the chat box and we will be discussing it at the end of the session. I'm sure this session will be very educative to all of you. Without further ado, let's start the session. First of all, I would like to introduce our first panelist, Gokcin Cinar. Gokcin is joining the Department of Aerospace Engineering at University of Michigan as assistant professor in January 2022. Her main research interests include aircraft system architecting, integration, and design with special focus on sustainable aviation concept. In her research, she utilizes probabilistic and statistical method and technique for surrogate modeling, design, space exploration, and decision making to analyze, understand, and design the complex system behaviors of an aerospace vehicle. For past 9 years, she has been involved in various research projects funded by governments such as NASA, AFRL, FFA, and industries such as Boeing, Airbus, and Ampere. So, uh, hi, ma'am, and we would like to welcome you. And I would like to call you to the stage, and so that you can introduce about yourself and the technical projects you are being involved in. So, the stage is yours.
Thank you very much. Well, first of all, thank you very much for having me here. It's a great honor to be here today on this panel with such great speakers and yourself as the moderator as well. So thanks for having me. And thanks for the kind introduction as well. So I'll go ahead and share my screen here. I have a few slides. Let me see. All right. Can you see my full screen?
Yes, we can see your screen.
All right, great. All right, so hello everyone. Today I'll be talking about the aviation side of electrification and why we need it and what are the opportunities as well as some challenges. As introduced, I am a new assistant professor starting in January at the Aerospace Engineering Department of University of Michigan, and in the past, I have been working as a research engineer at the School of Aerospace Engineering at Georgia Tech, where I also got my PhD degree from. And in the past 9 to 10 years, I've been involved in various funded research projects, mostly on sustainable aviation technologies, and electrification has been the main part of my research so far. All right, let's roll back a little and start from the beginning of this story and see how aviation affects climate change. Well, since the Wright brothers aircraft really depend on fossil fuels, and as a result of the products emitted by the fossil fuel combustion, especially at cruise altitudes, the global aviation industry contributes to climate change, as we all know. And although it is not as much as the other transportation systems or other humanly emitted CO2, it is still very, very important for the following reasons. When we look at this chart here on the left-hand side, now let me open my laser pointer here. This is a chart by the Air Transportation Action Group. It projects the CO2 emissions by air transportation from year 2015 to year 2050. And here we are, if you look at the pre-COVID era, in 2019, aviation emitted about 915 million tons of CO2 in 2019 alone. And of course, there's a dip with the pandemic, with the aircraft being grounded. But really, the business as usual, we left it here, and we do expect the demand to keep increasing after the things get more and more normal, and we return to business as usual. And that's the top line here. That's what you see when we get to business as usual. We expect the demand to aviation to increase actually about at 3% annual rate in revenue passenger kilometers, and this is going to continue through year 2050. And as a result of this, we do expect the CO2 emissions to grow with this demand, and we project about 1,800 million tons of CO2 emissions in year 2050 if there's no action taken against it. When compared to 2019 levels, this is almost 200% increase compared to 2019. So we need to do something about this, obviously. And if you know about the aerospace industry, then you know that the turnaround times are pretty long in our industry compared to automotive industry, for instance. In order to have something flying in the air, we need to take action very early on in the game, and that's why we need to act now. Actually, we have been acting now, but we are, when we say we are working on something today, we are really looking for it to go into effect in 10-15 years from now on. So we have some goals. Actually, ICAO has some goals that they set about almost 10 years ago. And this has been a very important topic for a while. And there are some goals that they've set that you can see here, such as the 2% annual fuel efficiency each year until 2050. And then we have the carbon neutral growth, which means that we would like to keep the CO2 emissions at a normal 2020 level. 2020 wasn't normal for the world. So of course, we are actually talking about pre-COVID-19 levels here. So, and then we have the very aggressive goal of reducing net CO2 emissions by 50% by year 2050 compared to 2005 levels. And in order to do that, we have some technologies as the aerospace industry. We are looking at some technologies, some improvements in operations and infrastructure, technologies such as sustainable aviation fuel, which has this impact, reducing impact of CO2 emissions as projected here. We can improve aircraft operations and the infrastructure, which could further reduce the CO2 emissions. But none of these, the incremental technological, operational, or infrastructural improvements, they will not outstrip the effects of growth in demand through year 2050. So we do need more radical and disruptive technologies to meet these aggressive goals. And of course, one of the most promising technologies is the electrification of the aircraft propulsion system, which can significantly reduce or even fully eliminate fuel consumption. And it can also enable affordable and quieter flights compared to status quo. Right, so let's summarize some of the advantages that come with electrification of aircraft propulsion systems. I already mentioned the reduced zero emissions on flights. Electric machines are less noisy than internal combustion engines, as we all know from really silent electric cars. And the cost of operation is also expected to be lower than what it is today. In addition to this, a very important role of electrification in aircraft propulsion systems is that it can bring great propulsive flexibility, which is one of the enablers of new ways of integrating the airframe to the propulsion system. And that's why you see these different aircraft concepts becoming available with propulsion system electrification. I'll show some examples in a few minutes. Other than that, electric machines have significantly higher efficiencies than gas turbine engines and piston engines. They also don't lapse with altitude. In aviation, this is a very important factor in terms of the performance and sizing of the propulsion system. So gas turbine engines, or I should say air-breathing engines, lose their power as you climb as you go higher altitudes because of the changing air density. We don't have this issue with the electric motors, which is really promising. So whatever we get on the ground at sea level conditions in terms of electric motor power, we are able to get that at 30,000 feet of altitude, which is not really the case for gas turbine engines. They're also scalable, more reliable, maintainable compared to conventional propulsion systems with moving parts. So these are all the benefits of electrification that we love and we would like to utilize in our aircraft systems. Well, now, of course, there's a dark side to the electrification, and we must know these barriers very, very well in order to overcome them in our design. And the main bottleneck with the battery-powered electric systems, as you all know, is the low specific energy of batteries, which is basically the energy to mass ratio. So this is especially important for aircraft applications because aircraft are very, very sensitive to weight. And we would like to make them as light as possible, safely possible. And batteries really don't agree with this mode of making our systems lighter. And even the state-of-the-art batteries have so low specific energies that we can't reach the same range and payload capabilities of the conventional systems. And with higher levels of electrification, the more we use the battery weight gets so heavy that the entire design becomes infeasible. Some other issues include thermal management challenges. We are dealing with very high power levels, electric power levels that we have never dealt with on aviation before. We are talking about megawatt electric power systems, and we need to basically find a way to manage the thermal issues of these systems. We are also talking about substantial changes to the propulsion system with completely new technologies. So certification is really a big challenge with these novel designs. And there needs to be a lot of research and development to develop aircraft-grade technologies, which requires serious investment. And of course, there's the charging side of it, especially for aviation. This means infrastructure changes at airports, which is costly and cannot happen overnight. And we also need to think about the life cycle cost of CO2. So when we look at the aircraft and reducing its emissions, that batteries might help, but also we need to take into account how much power is needed to charge the battery on the ground. What is the local power grid? Where's that power coming from? Is it a renewable energy source, or is it actually impacting the CO2 levels on the ground as well? So we really need to look at it from a life cycle perspective. And as an electrified aircraft researcher, my job is to be aware of all of these challenges and uncover others, and try to find clever ways of leveraging electrification or help setting technology development targets to make electrified aircraft feasible. I promised showing you some concepts. And there are many, many more, but as you can see here, these concepts really vary from each other. We have the vertical takeoff and landing aircraft that are powered electrically, something we call eVTOLs. So you would see these designed in air taxis. We have smaller to larger aircraft going from left to right. And actually, when we look from the outside, these are all different systems. Because of the flexibilities that I mentioned earlier on that are enabled by electrification, we see these changes in the aircraft design. But really, when we look at inside of these systems, the propulsion architecture, meaning how we connect everything together in the propulsion system, that's also very, very different in each application. So we have different propulsion architectures, like fully electrified systems for smaller systems especially. We have hybrid systems where we have more than one energy storage like battery, but also fossil fuel. And then we have turboelectric systems, which do not necessarily have batteries, but they have generators. They generate electricity with the gas turbine engine and use electric motors. And somehow they try to optimize the operation of the engine to save some fuel. And usually we see these solutions for larger aircraft with higher range and payload capabilities. So, to sum up, electrification fundamentally changes the relationship between the propulsion system and the airframe, creating a rich and complex design space with many opportunities, but also challenges that we need to overcome. And there are also many different architectural designs creating a combinatorial space in terms of the physical systems, but also there is the question about how to operate them, how to optimize the power management strategy for each architecture, which really depends on the architecture. There's also a lack of historical data. Historical data is very important to us aerospace engineers because we really heavily rely on them, especially at the conceptual design stage. But for these novel systems, we do not have much historical data we can rely on. So we need to create physics-based models and we need to use them in the conceptual design. We need to change the way that we've been using these traditional sizing methods and develop new ones, which is really exciting for me. And my research objective is basically to explore this new aircraft design space enabled by these revolutionary technologies such as electrified aircraft propulsion in order to maximize the environmental, societal, and operational benefits, and hopefully eventually minimize aviation's impact on climate change. That is it from me. Thank you very much. Stasia, I can't hear you. I think you're muted.
Okay, sorry. Thank you, ma'am. Thank you for sharing your valuable information and knowledge on electrification of aircraft system. It was very informative, and I hope it would be the same for our participants as well. So, a quick reminder. So, if you have any doubts, please put it in the comment box, and we will be discussing it to the respective speaker at the end of the session. So next, I would like to introduce Satarupa Bal, our next panelist. So Satarupa Bal received BTech degree in Electrification Engineering from National Institute of Technology, Rourkela, India in 2013. So she took her PhD from National University of Singapore on the topic power electronics, and her research interest includes switching methods and modulation technique, design and analysis of high current and high frequency bidirectional power conversion for microgrid application. Now she is working in Oak Ridge National Laboratory as postdoctoral research associate. We are really happy to have you with us today. I would like to invite you to the stage to give a brief introduction about yourself and the technical projects you have worked on or you are involved in. So the stage is yours. I think you are muted.
The same problem.
Yes.
Okay.
Yeah, we can hear.
Can you see my screen now?
Yes, I
You
can
see my
see.
screen. Okay. Yeah. So thank you, Staji, for organizing this, for making sure that the session flows well, and thank you to WITEC for having me here. So. I'm Satarupa Bal. I'm currently working as a postdoctoral research associate at Oak Ridge National Laboratory here in the US. So I thought that I'm going to present it a little bit different, where I'm going to give my work experience along with my educational flow. The reason I did it is I have had a variety of experience. I have worked on different kind of domains all through all these years. So I started my bachelor's. I started with my bachelor's from National Institute of Technology, Rourkela, India, from India, and I moved to Singapore to do my PhD from National University of Singapore. So there I was working on my primary focus was on a power electronics, where the idea was to develop modulation techniques for energy storage applications. So when I say energy storage, I mean for residential applications or for electric vehicle application where the energy storage is the secondary power source, not the primary. So one of the major contributions that we had was how to improve the medium to light load efficiency for this wide voltage range application. So the key part of my contribution was we were trying to tackle these contradictory requirements through modulation techniques without using any additional equipment or any additional components in the converter. So as a result of the work that I did, I was awarded Best Thesis Award from for in the PhD category from Industrial Application Society in 2018. So followed by that, I moved to Rolls-Royce Corporate Lab in Singapore, where I was working as a research engineer fellow for almost a year. So there I got the kind of work that I did was very different. I was no more working in the power converter design, but I was working on a solid state circuit breaker for passenger aircraft application. So we heard in detail by Dr. Cinar how electrification in transportation is a hot topic. So that's so just to give you an example, EFNX was one of the work that Airbus, Siemens, and Rolls-Royce were working together. So the black portion that you see here in the figure is something that they were trying to uh, electrify it with a DC distribution system. So when it comes to the DC distribution system, one of the critical aspect is protection. So how do you protect the network? So typically what happens is I will not try to delve a lot into the detail, but typically what happens is you have electromechanical based circuit breakers that we see widely around us, that is used to break the AC current. But here we are talking about a DC distribution where we do not have the zero crossing. So Rolls-Royce was focused on something innovative solution. So we were looking into a solid state circuit breaker application, and among many advantages that solid state can offer, one of the critical thing that kind of drew the attention was it did not have any mechanical component that's turning on and off. So we were able to avoid any form of arc that could potentially happen. And as we know that when it comes to aircraft, reliability and safety are one of the main critical aspects that has to be maintained. So I got a chance to work on something very interesting, a solid state circuit breaker, where we try to build the hardware around and demonstrated how we were able to break hundreds of amps without causing any kind of arc. So that's what I was working on when I was in Rolls-Royce Corporate Lab. Then I moved to Belgium, where I was working for this company called C plus T Power that rose to fame when they won this Little Box Challenge back in 2015 and was awarded $1 million for their innovative solar inverter architecture. So there I was working as an R&D power electronic engineer, again for about a year. The work that I was doing there was again very different for a different kind of application. So I was working on a 5G telecom application where the constraints were very severe. As we know that the entire world is now moving towards 5G, but what we don't know is they wanted to move to the 5G without any additional infrastructure. They wanted to make use of the conventional 4G infrastructure that we have in place and move to 5G. And when I say 5G, we mean higher power processing capability, more number of power converters that we want to add, and all that within the same space that we have available from 4G. So that required us to have the innovative DC to DC topology or DC to AC inverters topologies that were able to meet the required power density and also enable high efficiency, because of the size constraint we could not allow a higher power loss. So during my stay at Belgium, we were able to conceptually and through at prototype level demonstrate an interesting, I would say, DC-DC converter that enabled us to push the efficiency to 99%. And we had some innovative magnetic designs that helped us to achieve our required power density. So without saying much, which I'm not allowed to, but what we were able to demonstrate the the requirements of 5G telecom application within the same constraint. So that was an interesting challenge. Being exposed to a company, I was able to work on. Now, followed by that, I moved to US. I'm in where I'm working as a postdoctoral research associate at Oak Ridge National Laboratory. So here I'm working on two projects. One is again going back to the solid state breakers, but this time the requirement is to have a universal solid state breaker. So a breaker that can be used for a DC system or an AC system. So that's the kind of work that I'm doing here. And very recently I moved to this interesting project where we are looking at a EV charging infrastructure. So, and we are looking at how to detect the anomalies and what are the different mitigation strategies that we can have. So just to give you an overview, so we are looking at a EV charging infrastructure of more than 5 megawatt, where we have different kind of energy sources at play. We have the main AC grid coming into the picture. We have energy storage and as well as we have the local generation like PV. So when all these different kind of source and load come together, the dynamics are very different. So how do we study these dynamics, and how do we study how the different charging rates of different vehicles at different point of time affect the overall ecosystem? So that's something that we are trying to explore here at Oak Ridge. And what we found out was, instead of building this entire system in the simulation platform, to get a more realistic feel, we are opting for hardware in the loop platforms like Typhoon or Opal RT systems. And we're trying to build the switching models of the different power electronics that are used to integrate these energy sources and load. And the essential idea is, whenever there's a fault happening at any of one of these locations, or there's a cyber attack or a communication failure, how do these different sources and loads interact with each other, and does it lead to any catastrophic failure? So the main idea is that we do not want, in a real scenario, we do not want the charging experience of the consumers to be impacted. So how do we maintain that goal while ensuring that our grid does not fail? So that's a very interesting project that we are working now, and we hope that the results that we get is something that would be of use for the utilities. So we are working closely with utilities as well to give a real feedback of what could happen when we try to implement or integrate more electric vehicles, more charging infrastructure into our existing ecosystem. So that's the work that I'm doing. And the interesting part is, these are the different elements, the different kind of applications. And what has helped me is to get a wider perspective, a broader perspective of the different elements that play a role while we are thinking about certain applications. So that's what has been my research experience till now. Before I move forward, since this is more about transportation electrification, I thought I would talk about how Oak Ridge National Lab has been one of the first to demonstrate this wireless charging demonstration. So we have successfully demonstrated more than 200 kilowatt of power transfer over 15 inches, with demonstrating more than 90% of efficiency in the power transfer. So as you can see here, we have to replicate a real life scenario where you would have a vehicle just passing over a wireless charger. We have built this infrastructure which just moves and keeps charging along the path. So this has been one of the successful demonstrations, and Oak Ridge National Lab is known in the power electronics community also a lot because of their wireless charging demonstration. So, since we have a lot of young professionals here, I thought I would touch a bit on the different aspects of career growth that I have realized has helped my growth and my exposure to different fields. So, one of the key aspects is collaboration. It could be within the group, it could be interdisciplinary, cross universities. And what I have realized is it not just helps us to broaden our knowledge, but also helps us to establish that network, which is very important. Which also brings me to the second point of networking. So one of the important thing that I have realized is important for your career growth is networking. So, for all the young professionals who are listening, who are joining, or the budding professionals, I think there are lots of IEEE groups which can give you that kind of exposure, that which can help you to network with different kind of people. Make sure you attend conferences. There are a lot of funding opportunities now from different IEEE groups. So, especially for students, try to make use of that. Try to attend conferences. Just to give you an example, this opportunity today that I have, if I think back, I'm sure I can trace it back to one person that I spoke in a conference that helped me come here. So it's a long stretch, but it always helps. Networking always helps. Make use of LinkedIn, the LinkedIn professional that's available to network with a wider group of people. The third and the most important part is for career growth is improving skill sets. So now with so much information, the knowledge is not just restricted to universities and textbooks. There are lots of online courses, especially for power electronics. There are some very good courses in Coursera. There are some very good courses in Udemy regarding the different tools. So try to make use of those to improve the skill sets. There are different capstone projects that can help get a complete picture of any project. So try to make use of those, and that would help one to set yourself aside than others. So this is what I thought are the different or critical aspects of career growth. So I want to conclude by saying what are the career advices that I have received all these years. Finding mentor, and when I say finding mentor, I don't mean finding one person who can guide you through your entire career professionals. It's there are many people we meet through our lives. So, grasping something important from each one of them is what is critical, I feel. So, the second one is open to multiple career opportunities. So, if you see, if you look at my journey, I have moved through different continents, trying to work on different things. Even though the essence is the same, it's related to electrification in different parts of transportation. It's related to power electronics, but it still gives you the different kind of exposure because I have worked in different kind of roles at university, in a national lab, in a company. So that helps you to gain that confidence of fitting in to any kind of job role that's been thrown at you. So, open to multiple career opportunities is something that I feel can help with the career progress. The next and the last and the most difficult one that I'm still struggling with is how to think ahead and plan for the next 5 years. It's okay to not have a concrete plan, but just a rough plan is what is would help to set your path. So these are the advices that I have received, and I thought it would help all the young professionals who have dialed in today to listen to this talk. So that's all from my side. Thank you so much.
Thank you, Satarupa, for a very good presentation. I think it was very useful, for the target audience, that is young professionals. I hope they have learned a lot from your career experience, and I think it's quite relatable who to those who wants to try different things, right?
Yeah.
So it was very impressive, and we have a bunch of questions. I think we can go to that discussion later. So let's introduce our next speaker. So next we have Simay Akar. So Simay is a very familiar face to all of us. She has a lot of positions and responsibilities within IEEE and PES. So she's our PSYP chair and also the global chair, general chair of Powering the Future Summit. So Simay is a entrepreneur with a reputable corporate industrial background and experience in energy industry. She is specialized in photovoltaic manufacturing, battery storage for electric vehicles and renewable energy technologies and clean energy market development. Simay is currently the CCO and co-founder of Innoses, and she is, as I said, she holds very a lot of positions in IEEE, and she is the founder of this WITEC community. So we are really happy to have you here, Simay, and thank you for your time. So I would like to invite you to share your journey and your technical contributions to our participants. So the stage is yours.
Stacey, thank you so much. And thank you for moderating and making all these great initiatives happen. Hello, everyone. And so I would like to share, my background a little bit since, just like we're introducing actually women in tech, so like IEEE tech community. And I would like to also address some of the highlights from my field. One second, please. Okay, so I hope it's visible. So this is very first panel discussion on behalf of Women in Transportation Electrification Community. So again, that's really special for us, all of us, and also our very first Powering the Future Summit 2021 by IEEE PES Young Professionals. So like this collaboration is very important. And also I'll just like mention a little bit more about IEEE Tech and what is our women in tech community later. And so like what is the relationship with power in our society, why this collaboration is important. So first of all, I would like to briefly mention about myself. As Stacey already introduced, I'm the CCO of and co-founder of Innoses, so like lithium-ion battery cell manufacturer and technology solutions provider. So like I'm an entrepreneur, but I started my journey in the photovoltaics industry. So I lived and worked in China and Turkey, mostly like hold like international roles in commercial side. And so that's actually my passion for the clean energy technologies. And I started this journey in the lithium-ion battery industry and how I got engaged more in transportation electrification field. And also I'm volunteer since 2007 and I serve already several roles in different organizational units. But so I would like to highlight this IEEE Tech Transportation Electrification Community and Partner Society with several roles I'm holding right now as I'm chair and or young professionals and the founding chair for Women in Tech. And of course, I'm from Region 8, living in Turkey at this moment. So you can get more information from my website and happy to stay in touch with all your questions. So my field, like, and as I said, I'm in the lithium-ion battery industry right now, targeting energy storage, electric vehicles, and smart applications from 3C for 3 segments. So like battery cell and battery solutions and products. We are focusing as Innoses. So like I would like to just address a little bit about battery technologies, the role of battery technologies in transportation electrification, and also why it's also important in whole clean energy technologies. I'll try to keep it brief so we can have more questions. So we're actually seeing how I ended up in battery technologies and slightly shift from photovoltaics industry, which is still connected and relevant. So it's actually seeing the future direction and innovative solutions for clean energy technologies. I also realize, and my partners at this moment, so we realize the potential future direction for the battery technologies, how to deploy the technology for the future of the cleaner transportation and also energy storage. So again, referring to IRENA's innovation landscape, so there are so many different opportunities for many of us. So I would like to address here among many of the 11 listed innovative technologies here, we can see this direction for the e-mobility segment, electric vehicles, smart charging applications, and also the batteries to apply for ESS, and all digital technologies, especially on Internet of the Things, artificial intelligence, big data, and blockchain behind, could be very supportive for each technology, and they play very important roles. And we're seeing actually the change in the also transmission lines and the power generation. So we are seeing also increase in the renewable energy resources, but we are today more flexible in our structures. So batteries can be also used in the energy storage technologies. So the technology behind is that these batteries are actually in the same direction. So for the battery technology providers, so it's another direction that can work to together at the e-mobility and also energy storage in different forms. And we are seeing electrification and e-mobility as a rising star in all the clean energy technologies. So that's what we are passionate for today. And today, and our distinguished speakers already mentioned in different forms. And the batteries are today less expensive, safer, and longer lasting, which is also helping the future direction of the transportation electrification. And also, I would like to address few important future this direction for the transportation electrification. So we will be seeing autonomous vehicles. We'll see big improvements in every single year. And also we're just we're seeing actually the importance of smarter and greener cities, more sustainable and green cities, just not only smart and sustainable cities as a future direction. Today we're just the number of these kind of cities are increasing, but also just here in the electric vehicles and also e-bikes as an end user target. So they play very important role to change the urban mobility. It's actually a revolution. And we are just also focusing on electric battery recycling. So these recycling, there's always an environmental concern behind the batteries, but actually the recycling circle plays very important role and actually address all the concerns. So the right usage of the circle, lithium-ion battery recycling, will bring a lot of environmental benefits and also help to improve the technology. So we are also seeing the green hydrogen as a future direction, which will be very important also in the electrification of the transportation electrification. And hydrogen as a battery also, just is another interesting future direction. And hydrogen EV vehicles are also a big possibility. So not only electric and hybrid vehicles. So we have also very, just interesting improvements coming up from hydrogen electric vehicles. So there are so many applications of the solar cells that we know we're, they're just a trend, innovation innovative solutions for the PV applications, I'm referring the floating solar and agricultural PV plants where we use the land more efficiently, but also from the electrification side. So we are also seeing these solar cells can be applied, and also, just like technology improving and deploying with the hybrid and electrified transportation systems, and also solar car parks and solar roads are also crucial in, just like and it's important to integrate them in the sustainable and green cities. So today we're seeing more digitalized energy production and consumption. So like the end users, and actually plays more important role where we are actually referring the traditional electricity supply chain is no longer one direction. So we are actually part of as like producers and consumers. So we play two different roles in this chart. So the new energy supply chain already has the prosumers, which also means it's a new terminology. So like a prosumer and consumer, producer and consumer. So where we're also seeing the battery storage systems in our charging, smart charging applications are already integrated in this energy flow. So like we are more connected to grid systems, and also we are seeing the new technologies in the smart charging electric vehicles, and distributed generation plays more important role in this system. So today we are more flexible, and so like it was highlighted by Irena also, like the electrification, decentralization, digitalization are top three main category for the innovative trends. And that will be also very important for the future of the transportation of electrification. So I will keep the future direction more brief so we can have more time for the discussion. But I would like to highlight also, we have a new community under IEEE Transportation Electrification Community called WITEC, as Women in Transportation Electrification Community. If you're not member of TEC yet, IEEE TEC, please join us. If you're a member of the sponsor societies that you can easily subscribe from your membership, please just like check out our website. So WITEC is also formed to support, empower, who are already, just like role models in this transportation electrification field, and our members. So we're here, and the WITEC community is here to support, empower, recognize the success and achievements, all the accomplishments of our members. So you don't have to be just female, but of course we are here to address diversity and inclusion in our community, and support our members, and learn from our members, and inspire and shine together. So that's why we organized the very first panel session on behalf of Women in Tech, and we will have more. So the collaboration was important because one of the main sponsors, so behind IEEE Transportation Electrification Community, there's important stakeholders. So like it's a collaboration between several IEEE societies. Pioneer Society is one of them. As Young Professional Committee of Pioneer Society, we wanted to start this collaboration by hosting the very first WITEC panel under the Powering the Future Summit by IEEE PES Young Professionals. And if you don't know us yet, so you can also check our website, and we are a Young Professionals group, which is like after the graduation within 15 years. So if you're already IEEE member, and if you subscribe the IEEE YP membership, and if you have the Pioneer Society membership, so you're already our member. So we are here to support each other with many initiatives. You can check all our projects, and Powering the Future Summit is one of the most important initiatives we started this year. So again, here's my contact details. You can get more information from my website and contact details. Also, Pioneer Society and IEEE Transportation and Electrification Community websites will bring more information. I'll be happy to also answer if you have more questions, and we still have time for the questions. Okay.
Thank you,
Thank
Simay.
you so much.
Thank you, Simay, for a wonderful session. Thank you for explaining your field and about electric vehicles and also touching up on WITEC. So, for those who are not aware much about WITEC, I hope they have understood or got a little bit understanding about this community. So, right now, I will add all our panelists to the stage so that we can start our panel discussion. So, yeah, so basically we have some questions in the chat box also, but we will come to it later. So first I have prepared some questions. So first we will discuss that. So my first question I would like to ask Dr. Sinha. So I can see that you have you have a lot of publications. You wrote a lot of papers, a lot of things. So can you just point out one publication that was quite challenging for you? Okay, can you share your experience? Because there will be a lot of people in our participants who are interested in research and writing papers and all those things. So what will be your message, or can you share your journey that you have faced and the challenges you have faced and how you overcame it?
Sure, thank you. And I must say I enjoyed the talks given by Simay Akar and Satarupa Bal very, very much. So I was listening very, very carefully. I think they gave great advice, and I'm gonna rewatch this again later on YouTube. Thank you for your questions, Taji. So, like I said, I've been working as a research engineer at Georgia Tech, and before that, I've been doing my PhD. So I've been in academia, but my situation as a research engineer, it's a little bit different than the conventional like academy or like being a postdoc, for instance. You are more involved in the academic research. I have been involved very much in the academic research, but also working with industry pushed me to publish most of my work in conferences rather than journals because of some of the limitations brought by the industry. You have to hide proprietary data, you cannot tell too much, but also being under the umbrella of the academia, I do want to publish. So that was really that has been the most challenging part for me. How do I show my work without while respecting that proprietary nature of the data that I use in my research with the industry? So I can't say that one publication was the most challenging, but this has been a pattern throughout the years. So now that I'm transitioning to the academic faculty from research faculty, I'm hoping that this is going to be a less of a challenge, but it's always a challenge. So what I would recommend to young researchers is to make their goals from the beginning. If they would like to publish, especially if they want to go into academia or stay in academia, publishing is very, very important, as we all know. So when you are starting a research, especially if it's a funded research, because if it is independent research and development, then you can publish it as you like. But if it is funded, then make sure your goals are very clear to your sponsor as well. If you are doing fundamental research, then you have a right to publish, but you need to communicate that with your sponsor, especially if you are funded by the industry. That's a very important thing to agree on from the very beginning. So that's the from my experience, there are a lot to say about publishing, but that's from my point of view one of the most important things. And I would also say publishing in journals is very important for your academic credibility, but also publishing at conferences, like Satarupa was saying earlier on, in order to have a broader network. That's I found it very, very rewarding. I find these like conferences a great place, the perfect place, especially when it is in person, to make new connections. So I would say publish in diverse organizations and settings, I should say.
Thank you, ma'am, for answering the question. And when I was looking into your website, I have seen that you're calling for a fully funded opportunity. I could see one opportunity in your website for calling for PhD scholars or some young researchers to work under your project. Can you give, if it is okay for you, can you give a little bit information about that?
Yes, of course. So, if you are a prospective PhD student, meaning if you would like to do your PhD on especially aircraft electrification, but on a broader perspective, sustainable aviation research from the perspectives of aircraft design or aerospace systems design, then I have a few PhD students positions open, fully funded in University of Michigan. The application deadline for the PhD students are December 15. That is an application to the university, and then after that deadline, I'll be in touch with the prospective students who would like to do their PhD with me. Again, this is a fully funded position open to everyone whose background aligns with what I'm looking for, and they can go to my website to find the details. My website is basically my first name, last name.com. So it's gokcincinar.com. So you can find more details there.
Thank you. Thank you, ma'am, for sharing these details with our participants. So we are happy that we could also outreach a little bit about your opportunity using our platform. So thank you so much for answering the question. So my next question is to Satarupa Bal. So actually nowadays everyone is moving to digitalization, so all the, even if we conduct a conference, most of the papers that we get is either using AI or ML or things like that. So since you have worked in a lot of different domains, okay, what is your opinion about digital? Have you worked on digitalization projects or anything related to that? Can you put some light into that topic?
Yeah, so it's very interesting that when I started my career, digitalization was, especially in power electronics, was not so prominent yet. It was just starting. The AI, the concept of AI was still new. But now, when I see in power electronics, digitalization has started to play a very critical role. So I don't know if many people know of this company. So there are different companies who are looking at, for example, there is Frenetic, with whom we were trying to work a bit. They were looking at how to use AI for magnetic designs. So, and there are many such small companies who are trying to make use of the artificial intelligence to do this self learning instead of having a person go through those iterations. Because, especially if I just have to take an example, a magnetic design, it's not a one shot design, it goes through multiple iterations. So, instead of having one person sit there and go through those multiple iterations, they are trying to make it all automated. That's the term that being that's very popular now, and it's, we are seeing that impact even in power electronics. So that's what I was talking about, the cross collaboration, where you get to work between different domains, kind of start interacting with each other. um, Another such application which has become very critical now, given that we now have power electronics at everything that you touch around you has one or the other form of power electronics. So it has become a very integral part of our life. So how do we make sure that we are always ensure the reliability of our power electronics? Because as you know, there are several components that are susceptible to failures. So there are a lot of research by different groups where they are thinking about how to make use of artificial intelligence to predict failure of different components of a power converter, be it magnetics, be it semiconductor devices. So this is where the power electronics is moving. It's no more just about a power converter design, but it involves now using, you now have to learn how to code, you now have to have some basic idea about artificial intelligence, how to make use of the resources that we have in hand to ensure that the reliability of the power converter is ensured. So I would say this is a very interesting time for anybody who wants to get into power electronics, because you have so many opportunities now at hand, that this is the best time to get into power electronics. Coming to my personal experience, I personally have not done any artificial intelligence, but what we do is, so we talk about artificial intelligence, but we are missing one critical aspect, is data. So where do we get the data to train our machine learn, to do all those machine learnings? So we are kind of in the back where we are trying to collect those data, trying to make sense of those data, which could be used for artificial intelligence or for machine learning. So yeah. So that's what I have been doing, collecting all those data and making sense of those data.
Thank you. Thank you, Satarupa, for sharing this information. And I hope our participants got a rough idea about, how to start, or how digitalization has opportunity, increased the opportunities in this field. So thank you for sharing this information. So my next question is to Simay. So Simay, actually, you shared a little bit information or the mission of Women in Tech, right? So, can you just explain to our participants how they can involve in VTech? Like, is there any opportunities, or basically, also you can cover, what was your personal inspiration to start this Women in Tech community? So, these are the two things that I would like to answer. I think you're on mute, Simai.
So can you
Yeah.
hear me now?
Yes.
Perfect. Okay, the intention behind was just like giving recognition to our volunteers and their achievements in the community. So like because we have so many successful members, and they're role models. They're just like they are actually they're shining. They're like inspiring. But we just need to give that recognition by just forming a community under our transportation electrification community. It was the idea behind, and it's not just for women. So it's like we target diversity and inclusion in the community. So, and just like more diverse panel sessions, or just like speaking opportunities, further more recognition opportunities for our members. That was all about the women in tech community. So like and we just like started as like tech has a steering committee. It was approved early this year. So we are just like discussing about just like the speakers pool, and having bi-monthly webinars, and having these kind of collaborations with the technical societies that we're working together, and have more recognition opportunities. And there might be new projects, but how they can join. If they are already member of tech, you're part of the community. But we will from like from our communication channels, we will have a subscription, just for the news. And also when we have a speakers pool for these similar events, that we will ask all our members in the tech community to sign up if they're willing to speak at these events and be part of the speakers pool. This is their first initiative. And whoever is member of this community, of course, we don't really focus on females, but of course, all our members are automatically member of WITEC. So how to be more active is relevant to the engaging the initiatives. And we will also have soon have an advisory board and new volunteers engagement. So once we have this call open, so all the tech members will hear.
Thank you, Simai, for explaining us, and thank you for sharing your inspiration behind VTech. So my next question is to Dr. Sinha. So you were being featured in a lot of newspapers, and I recently went through one that is in Turkey. The name of it, the newspaper is Milliyet Gazetesi. I don't know whether I'm pronouncing it right.
You
So
are.
so the topic of that article was there is a secret to success. Okay, so I couldn't read the entire thing because of it was in Turkey. So, is there any secret, for your success? If there is, can you share it with our participants?
Yes, of course. Obviously, I didn't choose that title. That was for the International Women's Day last year, and there were pieces or quotes from different women in Turkey, and I was a part of that group. And basically, I don't think there's a secret. There are many things that contributes to one's success, and it also depends on how you define success. But what I said there, and what I can share here with my peers as well, is to have, in order to get to where you want to be, you first need to know where you want to be in. And I'm not going to approach it as a 5-year 10-year plan, but I'm going to approach it as a dream. Everything I think starts with a dream, with dreaming something. When I was a little girl, I was always dreaming about becoming a pilot. And then as I grew up, that dream became something like, okay, I know I want to do like DIY. I love aircraft, so maybe I should be an aerospace engineer. That was from a very early age, but it can happen anytime in your life, in your career. And then I always dreamt about being an aerospace engineer. And as I grew up, you set those dreams as targets. Those dreams become targets. And when you achieve those targets, you dream about something else. I was dreaming about getting higher education in the US, and that became a target for me. So I worked very hard for that. And when that happened, the next dream for me was to, work on future aircraft designs, and then to have an impact on sustainable aviation and so on and on. I still have dreams. I think it's a very healthy thing to dream, and it's evolves as you take different paths in your life. You may not always achieve your dreams, you may not always realize your dreams, but that's okay. You are allowed to dream a lot of things. You don't have to stick to just one thing. When situation changes, your dreams can evolve, your dreams can change too. But I think, I don't think that's a secret, but that is just um, my thought process. Everything starts with a dream.
Thank you, Dr. Sinha, for sharing this. As you said, our dream should become our target, and one of the our previous president of India once said, we should always dream high. Okay, so thank you for sharing your thoughts on this question, and I would like to ask the next question to Satarupa Bal. Actually, we have one question for you from the participants, actually. So, do you think certification courses are considered valuable by the industries? Basically, that's again no experience. So, or do you consider them as a personal developments? So, this is the question.
So, honestly, no. So you can't really show the certificate to industry saying, "I have done this course, hire me." So it's that's not usually how that works. But having said that, it's not just for your personal development. It does account for your professional development, because there are some courses that you are essentially developing the skill sets. So you cannot show the certificate, but you can show the skill sets that you have learned through that course. So that's the key there, the skill sets. And whenever you approach an industry, what they look for is having experienced in working in a corporate lab, in industry and national labs. So what I see is they look at the skill sets that you have, not your degree. More than degree, they just see what are the different tools you can use when you come here. What is how can you serve as an asset to the organization in terms of the specific tool that you're bringing into the company. So I think that's where the that was my intention behind mentioning about the certification. It's learning those tools and developing that skill set.
Thank you, Sitarupa. And I think we have one more question. So, what was your reason for changing career path?
What was my reason? Multiple reasons. Sometimes there are some opportunities that came that I was not expecting. Sometimes it's there are personal reasons that drive you to move to a particular continent. So if you see, I have moved across 3 or 4 different continents, three continents. So it's it that I think, as Dr. Sinha mentioned, you don't have the plan, you have just a dream, an abstract dream of where you want to be, and there are different opportunities that just come, and you find it, maybe that's something I can try, and that's how you move. So it was not planned, nothing was planned. Coming to US was not planned, so but it's just the opportunities that came on my path. And I just want to take this opportunity to highlight that one of the big reason, or one of the the reason why how I came here was networking in conferences. So that's something I just want to stress for all the people listening in, is that's a very critical advice that I got maybe a little later in my career. When I look back, it would have helped me if I knew it as a student, how important is this networking in conferences to reach out to a wider audience, to to make yourself visible. That's how I think of when you attend conferences. You are trying to make yourself visible to a lot of people when you attend conferences. So yeah.
Thank you. Thank you. I think you have beautifully answered the question. So thank you so much. And I have one question to Simay. So Simay, when we come to entrepreneurship, actually there are, if there are 532 million entrepreneurs, 230 plus are females. So you are one of the entrepreneurs in energy sector. Okay, so what was your motivation in being an entrepreneur, and what was the challenges that you have faced?
Well, I'm seeing actually the challenges of being entrepreneur is just like the beautiful side, because those challenges are so valuable. They're learning opportunities in life. So like we should force our limits. So that's actually it's a kind of like a way of life. So when I force the limits, I enjoy and I see actually the development in every field, including actually personal development, but also like we're contributing to the community even better with those learnings. Like out of those challenges. So like for me, like as also I highlighted in my presentation, it was there's always an opportunity for the future direction for the technology that you're passionate for. So for us with my partners, so we found the right opportunities again. So it was a good time. It was a good opportunity. It was a just like a right time for the right resources, let's say, and we were actually passionate for some technologies with all our diverse backgrounds and similar backgrounds. And there was just like there were a few answers in the battery storage, targeting the electrification, well, electric vehicles, and also energy storage. So like again, so in the team, so we have diversity with our backgrounds, with our just like we are balanced, female and male, and different perspectives all together. So, and we had one vision to contribute sustainable development and clean energy technologies. And there was one of the emerging technology in front of us, which was battery storage. So that was very attractive. So like entrepreneurship opportunity, just like is different level for everyone in different stage of your life. So for us, it was the right moment. So if anyone considering being an entrepreneur, first you need to be very dedicated and passionate for the technology, and you should have a future direction and vision where that technology is going, because like there will be a lot of challenges in the way. So like you should be ready for those challenges, and you should enjoy them. So there will be return of investment, not for money, but by experience, not just for money. So like by experience. So you should enjoy this journey. And so my recommendation would be like seeing the future direction of the technology that you're passionate for, not only today, because we are contributing for a better tomorrow.
Thank you. Thank you, Simay, for answering the question. And one of my last question, it is common to all our panelists. So, what are the three skills, that you would recommend for young engineers? Some three, the three skills which you suggest for young engineers that they should have. Maybe we can start with Dr. Sinha.
Oh, I was just thinking. That's good. I don't know if I can list three things, but it's really a bunch of things that you need, to be a well-rounded professional. One of the things that was really that is really important and was mentioned a lot here was networking. So I don't know if I can list it as a skill, but what I would say is not being shy about sharing your career path, sharing your research or your I don't know professional development with others, and seeking answers from others, seeking advice from others is very, very important. So when we say networking, it's not about knowing people or exchanging business cards. It's really about having meaningful conversations on some professional level with others, and it's not always about with people who can help you. It's also everyone, with your peers, with students, young professionals, or the scale goes both ends. So I think that's very important. Another thing is to be up to date with the latest developments in your field. I find it very, very important. And one place you can get, you can educate yourself about the latest developments is usually the conferences, the conference proceedings. But it's very important to read scientific papers as well. Or if you're in the industry, maybe following news from the industry in your field, it's very important. So I would say networking, staying up to date, and let's see what is third. Maybe Satarupa or Simay will complete the third for me.
Thank you, Dr. Sinha, for answering the question. So, Satarupa, I think you can also answer the same question. So, what are the three skills required, in your suggestion? And also, you can cover this question which is asked by Rahul. So, I think the question is quite similar. So, your suggestion for beginners to work on EV charging stations and power electronics. I think you can cover the both sides, I think.
Um, to work on EV charging stations and power electronics for a beginner, it's hard to kind of comprehend what the question, what does he want to actually understand, but I would say a very good starting point to just get an idea, as Dr. Sinha mentioned. There are so many publications now that, or just reading some articles, there are a lot of magazines that are focusing on this electrification, be it the electric vehicles or the aircraft systems. So to just get the starting idea of where the direction is. So just to give you an idea that the US government is now willing to spend a lot of money towards the research on the EV charging infrastructure. So that includes extending the EV charging infrastructure throughout the US. So the target is to have completely electrifying the entire transportation on road. That means the buses, the trucks, and the cars. I think the goal is by 2030 or by 2050. I cannot recollect. It looks like there are a lot of opportunities that are there now. There are a lot of focus that's been driven towards electrification. And if one wants to understand where to start from, publications which gives you a little bit of depth, there are articles which gives you a little bit of broader perspective. So I would say, I don't know if I really answered this question, but if he's just looking for a starting point to understand the direction, I think these are very good places to start from.
Thank you, Satarupa. And can you suggest three skills that is required for, it can be anything. In your opinion, what, any particular courses, or you can suggest where the person should start if they are planning to do, studies in power electronics or a research in power electronics.
So I think I'm going to steal a lot of answers from Dr. Sinner. So um, I think Dr. Sinner did cover a lot of the critical aspects. Communication skills, I think that's something which is very critical. Um, and as she said, there is a, by when I talk about communication skill, it's the way you deliver, you highlight your work that you are doing. Again, it's about being seen, being noted, even though by one person, but the impact that you create, and that it can only be done by having proper communication skills. So I think a lot of researchers don't really understand this because we spend so much time in reading papers within our own system that we do not interact a lot of with a lot of people. That's true for a lot of people who are in research. So I think that's a skill set which is very critical for your career growth, and a lot of researchers should try to tap onto that as well. I'm trying to learn it, and I have realized that that's an important skill as you move ahead in your career. So and again, stealing from what Dr. Sinha said is there is a general notion that only somebody at a higher position can mentor you, or you can go for advice. But that's, I don't think that's really true. You don't have to be at a senior position to be a mentor. There are a lot of people who can be at senior position but not a good mentor. So and you don't have to wait for yourself to get into that position. For example, I don't think I'm in that position, but I'm sure I can be of help. From my experience, I can be of help for at least 2 to 3 people. So that's something that I think we should keep in mind. We don't have to really seek for somebody who is an expert in a field to ask for being a mentor. So that's something that I think is what is important to remember. And the last important thing is, I think there are a lot of people that say that how can one derive the confidence whenever you are speaking, or that's something that is said about a lot of women, that they lack that confidence. I think that's not really dependent on gender. It's all about how much you want to challenge yourself, how much you want to learn. um, the confidence, be it men or women, it derives from how much you know about a topic. And so I think keep learning, keep developing skills is that's the key to gain that confidence. That's what I have learned through these years. So the more learned you are, the more confidence you have whenever you're speaking about a topic. So that's all I have to say. I don't know if those are the three skills, but that's what is at the top of my mind now.
Thank you. Thank you so much, Satarupa, for sharing that. And I would like to ask the same question to Sumai. So,
Well, they were all well said. Probably we're all on the same page, and I'll just probably echo some, but I'll keep it brief. So, like, it's important to have the passion. Keep your passion. So, like, this not just skills only, but your passion will guide you. Just like and keep you updated and keep you motivated. And also, the secondly, it's important to be open for learning. So be open, and because it's so also, it was very well said, it's so important to see the future direction and ready to learn for the next. So like if you want to be, like if you already have the passion, so you would like to even contribute better, so you need to have this open mind set to learn better and to share your knowledge and inspire, because by sharing and caring, so we can only develop and improve better. And also the networking opportunities and self encouragement, let's say, and the confidence. It's also important to have the confidence. Don't hesitate to share your knowledge and speak up. And as like being a mentor, being a speaker at the panel, never just underestimate your own skills. So like by sharing and learning, so you can do better. But if you underestimate yourself, like you will close yourself for improvement. So that's also another way. So if there is an initiative to take, don't hesitate and go for it. So you can only learn and improve by taking more initiatives, and be change maker.
Thank you so much, Simay. And as you well pointed, passion is very important, and we have to keep yourself updated, as Dr. Cinar and Satarupa rightly pointed out. We have to keep ourselves updated, and I think going through the recent research papers and IEEE papers will help you a lot, and also be confident while we are sharing our knowledge. Yeah. So thank you, dear panelists, for sharing your thoughts on this. And if you have any closing remarks, you can say that. So maybe I can start with Satrupa.
So I would just want to thank you for moderating this entire session so wonderfully. And thank you to WITEC for giving this opportunity. I got to meet three more excellent and women that I know that I can reach out to in the future. So this is the opportunity that I'm talking about, that now I know three more people that I can reach out for future collaboration. Thank you so much for the opportunity.
Thank you, Sitarupa, and it was our pleasure to have you with us today. And Dr. Sinar, is there anything you want to say?
Yes, I would like to echo Satarupa's words actually. Thank you so much for having me here. And I'm really glad to have met all of you and have a chance to listen to you all. And I would like to say, to those who are listening to us, don't be afraid to reach out to people as well. Reach out to maybe like 10 people, maybe only two or three of them will get back to you. We all have busy lives and sometimes we get lost in that busy life, but don't be afraid to reach out, and also return the favor to others by helping others with your own expertise, like Saturpa was saying again. I think that is very important, and I completely agree with what Simay said about passion. So keep that passion alive. And again, thank you very much for having me here. It was a pleasure.
Thank you, Dr. Sinar. Thank you so much for your time. Thank you for coming, and it means a lot to us. And Sumay, anything you wish to say?
That was a wonderful session. Thank you for all the contributions for three of you. And just looking forward, just like more inspiration, more collaboration, and just like more things to learn from you.
Thank you. Thank you so much, Sumay. Thank you. Thank you, all our panelists, Dr. Sinha, Satrupa, and Sumay, for joining us. And I would like to thank Madhu as well for handling all the technical issues. So, thank you so much. Thank you for your time. And I would like to thank our participants as well for joining us. And on behalf of IEEE PSYP, I would like to give you a small in token of gratitude for sharing your time and knowledge with us. So thank you so much, and we are hoping for future collaboration. And I think we three, as Satrupa said, we four made three new connections today. So I hope to have you with us in our future initiatives. So thank you so much. So I think we can end our session now. So I request panelists to stay back for 1 or 2 minutes more so that we can have a visual photograph as a memory. So thank you everyone for joining us. So we are just ending our broadcast now. Thank you so much for joining. I hope you have gained some knowledge today. So thank you everyone.
Thank you.